I'll run you through that what we do at JSPL in terms of structures. And so JSPL, we are basically an 8.6 million ton facility in India and 2 million tons in Oman, taken together about 10.6 million tons. And we were the pioneers in the coal-based DRI in the world, and we are the largest manufacturers of coal-based DRI. So our DRI, we have about 1.8 million tons, and the balance we operate through the blast furnace route. And we have two plants, one plant at Raigad in Chhattisgarh, and the other plant at Angul in Odisha, which are the steel making plants. Plus we have a facility at Patratu in Jharkhand. These are the three plants in India, and within this we make about 8.6 million tons of steel. So these are the products that we manufacture. Angles, I think I missed one. How do we go? Yeah. So these are the structurals that we manufacture, and products that we manufacture structurals, rails, HR coils and plates, and wire rods and rebars, and also some amount of cast rounds and semis, which is utilized. And the structural that we are talking about in this, what we manufacture is angle, channels, beams, columns, sheet piles, and crane rails. Angles we manufacture from 75 mm to 250 mm. Channels we do from 100 mm to 400 mm. In beams, we do from 150 mm to 900 mm. In columns, we do from 150 mm to 400 mm. And in sheet piles, we manufacture one size, 400 into 170. Crane rails, we do all crane rails of 80, 100, 120, and 150. We also have a fabrication facility. In fact, we have three fabrication facilities. One is at Punjipatra, which is in Raigad. The other is at Angul, which is Odisha. And the third we have at within the Raigad steel plant itself. And between the three of them, we can do about 22,000 tons of fabricated structures. And these are the facilities which is there at each of them. So total area of 103 acres. And this is monthly capacity of 22,000 tons. And these are the machines that we have in these fabrication facilities. We have a plate butt welding line, we have a beam welding line, we have a beam straightening machine, the drilling and oxy-cutting and all these. So here we basically do more of the complex structures like the power plant structures and the road over bridges and things of those. And we also have a facility of designing in this. So in this particular steel plant fabricated facility that we have. And coming to the beams and columns that we manufacture. This is basically what we have. NPB, we do from NPB 180 to NPB 600, which is also called as IP 180 to IP 600. In the wide parallel flange beam, we have got wide parallel flange beam 160 into 160 to 900 into 300. In the universal beams, we have got UB 152 into 89 to 610 into 229. And in the universal columns, we do from 152 to UC 356 into 406. And we manufacture in all possible grades which are there. We do it in E250, E350, E310, E410, and E450. And we can give you in all the grades of grade A, grade BR, B0, and grade C. And similarly, we can give you in equivalent ASTM and BSEN grades. So this is what is the Wpb range that we have. In Wpb 160, Wpb, these are the basic WPBs that we do. This is the UB that we do. In UB, we do UB 203, UB 356, UB 457, all these sectional weights. So the basic advantages of this universal beam compared to a tapered beam and or a ISM beam is that there's multiple sectional weights that is available within the same dimensions. And that is what helps in optimizing the entire design. We we are also coming up with these three new sections, UB 610 into 305, UB 762, and UB 838, and they will be available by the end of this year. So this will more or less complete the entire UB range that is available across the spectrum. Similarly, in UC, we do UC 152, UC 203, UC 254, so all these sectional weights. So these are the multiple sectional weights that is available for in all of these. So W section is what is basically used in the US and Canada and those markets. So this is also the W sections also, we are able to manufacture these, and some are under development, and so almost from W6 to W33, we are able to manufacture right now. And a lot of these W requirements are being used in the solar projects in the US. And we have been supplying substantially to them, apart from exporting directly into the US and Canada. Then this is the IP range that I spoke about, that it is similar to the NPB that we manufacture. So in IP also, these are the various sectional weights that is manufactured by us. Then we have also the edge bearing piles and the HE range. So in this, these are the sections that we manufacture, HE 160, HE 600. So when it comes to structurals, you'll find that there is a lot of different families which are available right now. And that is what is manufacturing across the family, because each of these roll sets cost quite a lot of money. So giving the entire range across all the families is quite difficult for a producer, for a mill. But still, within these are the range that we have. So you'll see that it is quite substantially high, though it does not complete. Maybe in UB, we'll be able to complete the entire range. And in the other families, we are gradually improving the offerings. So this is the difference between an ISMB and parallel flange beam. This is, I think ISMB, the maximum that is available today is 600. And in the parallel flange beam, we can go up to 900. And the advantage is that in a tapered beam, the tapering is there across the flanges, and whereas in this case, it is totally parallel. This is another good development which has happened over the last 1 month, is that earlier IS 2778 was different from IS 808. So IS 2778 has now been merged in IS 808, and the effective date is 26th of August 2021. So I think from yesterday it is applicable. And this new notification has come in. So a lot of designers earlier were having this challenge that it was not covered in IS 808. So now that this has come, this will, I think, help in better designing of the steel structures. In the new products that we are developing, one is the sheet pile that we are also coming up with a sheet pile of 600 into 300. That is what is called as PU18 and PU18 plus. And we are also trying to reduce the current sheet pile thickness from 15.5 mm to 10 mm. And these three sections, UB 406, UB 450 into 160, UB 500 into 180. These are not UB. These would be specifically JSPL tailor-made section, you can say. 450 into 160 and 500 into 180. This has come in only with the consultation with designers that this is what could be required for a normal 9 into 9 grid or 11 into 11 grid. And this we have already started producing. And this is developed specifically for the commercial building segment. So steel structure advantages, I think all of us are aware of this. They are super quick, the ease in expansion and repair. The erection is faster, they are flexible. There's a wide range of ready-made sections, and they can take any kind of shape, and steel can be recycled. And most importantly, this is a point that I would like to stress upon, that traditionally the cost of steel structure is higher compared to RCC structures. But if you consider E250 grade vis-a-vis an RCC 500, TMT 500 grade, you'll find that the difference will be about 20-25% in terms of the cost. But the moment you move up the value chain and design in E350, E410 and 450, the cost can come down substantially, and in fact at E450, it can be much cheaper than the RCC. The normal advantage of a JSPL beam and or a parallel flange beam and a tapered beam, that this is where the maximum connection failure occurs at the bolt level. And if it is a parallel flange, then this problem does not happen. And the connection lengths are much lower when it comes to a parallel flange beam compared to a tapered beam. The cost advantages of a roll section, these are the two graphs that are shown. One is the buckling factor, which is there, which compared to a roll section and a built-up section. So the first graph is basically the roll section. The second line is basically a built-up section. The third is a cold form section. The third is a hollow section, and the fourth is a cold form section. So if you say as the slenderness of the structure goes up, the buckling factor becomes quite high. And as the buckling factor becomes high, then your cost of using a built-up section becomes higher when it comes to rather than a roll section. So the curve A basically talks about that. And the second curve that I'm talking about this in this blue and yellow line is what is currently the flat product prices and the roll section prices. You see that the plate prices over the last 18 months or maybe 12 months have been substantially higher. Today, a plate price would be approximately 72,000, 73,000 rupees landed into Ahmedabad. And whereas the roll section price will be about 65,000 rupees landed into Ahmedabad. So, and the way the steel industry is poised right now, with China now not dumping any material into the international market, and the way the iron ore and the coking coal prices are poised, currently it does not seem that the plate prices will come down. In fact, today the plate coil prices in US is about $1,850, whereas in India we are probably at around, US has a 25% duty, but including that it is $1,850. And India, it is currently ruling at about $900. So the way the international prices are poised, it doesn't seem that the flat product prices will come down in the next 2-3 years. And so designing in a roll section makes much more sense currently with these sort of price levels that are prevailing. Because when you take a plate section, you then build it up into a plate girder, I think the cost is another 7,000, 8,000 rupees. So today a plate built-up girder will be anywhere around 80,000 rupees, whereas a roll section should be available around 65. The other thing that I wanted to speak about was this use of high-strength steel. The high-strength steel in world over, it is available about up to 1100 MPa. And there's a amount of ferroalloys which is to be added, which basically increases the strength from the normal 250 grade. In India, still we are doing a lot of designing in E250, whereas almost world over, everywhere E350 has become, or S355 as they call it, has become the standard grade of design. So this is a saving in steel. This is on a thumb rule basis we have that if your yield strength goes up by 10 MPa or by 10%, then your steel consumption goes down by 5%. So suppose from E250 to E350, the change in MPa is 100. So it is 40% over E250. So on a thumb rule basis, it should happen that your steel consumption should come down by 20%. But there is always a cost of making a higher strength steel. And so if you look on a steel usage basis, the saving will be about 20%. But due to the cost increase in the ferroalloy addition, the saving in cost will be about 15%. Similarly, if you move from E250 to E450, the increase in strength is about 80%. And technically, you should be able to solve on a thumb rule basis, you should be able to save about 40% of the, in terms of steel usage, and about 30% in terms of steel cost. So I'll talk about the projects where we have supplied E410 and E450 grade steel, and which have come out. So E450 steel structures we have done with ITD cementations and Afcons for Kolkata Metro. We have done, as sir was talking about, the underground railway stations. So the whole of the Bandra Kolaba stretch, Dogasoma and ITD cementation, they have used E410 grade of steel structures. And even J. Kumar for a lot of their Mumbai Metro projects have used E410 grade structures. And the savings were similar to as of what I showed in the previous slide. Then we have done E410 grade steel for the Mahatma Gandhi Setu in Patna. A lot of wave bridges and the smaller trailers, those sort of applications also, a lot of customers have moved into E410 grade steel. Then we have E450 buildings in terms of Phoenix. Phoenix have been using this, they have been doing it through JSW Soilfield and Eversion Die. And they have used E450 for their entire, both in the plates and in the structures, for their commercial complexes in Hyderabad. And their steel consumption, they have been able to achieve almost to a level of about 5.2 to 5.3 kgs, and against a normal consumption of about 7.5 kgs. Similarly, the Nirupa Yambani Convention Center, which this came back to way back, I think it was almost 6-7 years old now, by the time the construction happened. This was by Eversion Die. And here also the entire plates and the entire structures that we have supplied was in E450. Then the Central Vista project, which is the new parliament development project which has come up in Delhi. There are 2 buildings which have come up in Africa Avenue, which are basically, when the buildings get demolished, the offices shift to these buildings. These entire buildings were constructed by E450, and this was done by Ahluwalia Contracts. Then we, our own fabrication division, we have done this Mist Avenue in Noida and in Alphatum, where we have used E450 grade steel. We are also supplying sheet piles in the grades of E410 and E450. And these are also regularly being used across the country. So I'll just run you through some of the projects wherein we have been doing this. So this is AIMS Bilaspur. This is of course in E350. And this is the Central Vista project that I was talking about. This is the final building that got constructed in about a year's time. And this was done by Ahluwalia Contract. Here the entire steel used is E450. And we supplied the structurals, and Tata Steel supplied the plates in this case. Then JSPL, these are the railway projects which are again, this is core is still in E250 grade. This is the project where Suzlon is using the these lattice hybrid towers, wherein they want to achieve a height of about 120 meters. With a normal plate, you can go up to 108 meters. So the bottom is with structures and the top is with plates. And here also the steel used is E350. Transmission line towers, the whole KEC, KPTL, PGCL projects, Sterlite projects, all of them have been using E350. This is the Embassy Tech Village in the Kia Motors plant, the Vijayawada plant. Then this is the other product, the sheet piles that we use. As I was talking, that it is something which is reusable. It can be, so this in this Pragati Migran project, I think L&T has used the sheet pile about 4 times. They have used it at one section, then taken it out, and again used it here. The Mumbai Metro Tunnel, this was the project that I was talking about, which was designed in E410. The entire, this is by Doga Soma and ITD Cementation. These are the Alphatum towers. Again, this is 13,000 metric tons of structural steel. This is the Cybertherm project, which is going on, 12,500 metric tons of structural steel. This is again the NICL corporate tower, again used in E450BR, still under progress. So this is the sheet pile that I'm talking about. We manufacture one size, 400 into 170, and this is how they look in terms of, and both of them basically get interlocked across the blocks that are there. So, and their applications can be water protection, can be in structures for waterways and way. And so these are the projects where sheet piles have been used. This particular picture in the middle is right at Nariman Point. This L&T has used this for the sheet piles. So a vibratory hammer basically drives it in, and then the sheet piles gets interlocked. And this basically it's a form of a steel wall that you see. And this has been very efficient when the recent Mumbai cyclone came, and the entire project site was unaffected in spite of the very high cyclonic waves that were there. And similarly for an embankment protection also, this is used. So that's all that I have. Thank you very much.